right, good morning, everyone. How are you today? My name is Amanda Milberg. I'm a senior partner sales engineer at Dataiku, and today I'm going to talk about strategies for deterministic LLM Ops. So what are we going to cover today? Well, first, we're going to review the LLM landscape. We're going to discuss where we've come from and where we are today. And we're going to outline key factors of consideration when building a large language model ecosystem to meet business needs. Then we're going to talk about strategies for LLM Ops. We're going to define the term LLM Ops. And in this definition of defining this term, we're going to talk about how this term even became to exist, why it's new, how we've evolved from MLOps. And in this, we're going to define differences between AI and ML workflows and LLM workflows. And then we're going to talk about some common problems and proposed solution for monitoring large language models in a production environment. And then finally, we're going to see it all in action. So I'm going to demo all of these strategies that we discussed in the second section in Dataiku, the platform. And we're going to mock up an LLM Ops solution based on those strategies to hopefully inform you and give you some guidance on implementing an LLM Ops strategy in your business. So to start, let's talk about that LLM landscape. So I'll ask a question of you to begin. How many large language models do you think have been developed and released to date? And I'm going to have you shout out numbers in a second, and don't think of every single model available on Hugging Face, but rather models released by notable providers. So ballpark numbers, let's hear it. 28, did I hear? Do we think more than 500? Maybe raise your hand. Yes, more than 500. More than 1,000. What about between 100 and 500? More than 8 and 500. Okay, a nice differencing of opinion, which is always good. So according to a report published this March, there are over 125 LLMs available in the model landscape. And we see the largest increase in 120% year-over-year growth from 2022 to 2023. And this makes sense, right? It corresponds with the release of ChatGPT back in November of 2022. And the expectation is that we should continue to see this graph go up. Models will continue to be released and this count will increase. But we can also expect some sort of a model churn. With new models being released, those will replace and be more performant than the older models. And we saw that with something like ChatGPT or GPT-4o being released. They said this is faster, this is cheaper, and everyone should replace GPT-4 with GPT-4o. And this stresses the importance of an organization to maintain flexibility, choice, and agility, to swap from models that might be released today with models that you developed in your applications in the past. And if we isolate just to the major players, the people that you think of when you think of generative AI, we're witnessing this race of innovation between the major players. Models are getting bigger, better. They're even becoming multimodal, the ability to reason across text, voice, image, etc. And we're seeing advancements in both the open source communities and LLM providers. And if we've learned anything over the last 18 months, it's that one size does not fit all. An enterprise needs a multiple LLMs to meet their business needs. But why? Well, each large language model has a different cost to serve. And this is dependent on things like, are you having a self-hosted model? Are you using an API provider? Do you just have text or chat completion capabilities? Or do you have this reasoning across text? And we also know there's differences between those task-specific models and those universal and all-knowing models. There's also this concept of latency and locality. Each model has a different response time. How does that response time matter to your organization? Maybe if it's an external use case, you want that latency to be super low. But if it's internal, it might not matter as much. We can also see a future with new and upcoming AI regulations that models need to be adapted to regional laws. A model that may work in the US might not work in Europe. And finally, what about a future where a model has to be local to a device like your iPhone? And then, of course, in order for these models to be adopted, they need to understand business-specific domain. We need to leverage or adapt models to a specific domain, just like we see with things like FinGPT. We need to make sure that we match a business problem with the appropriate model. And all of this means is that future enterprises will need to manage at least a dozen of large language models. A dozen. How did I get to that number? Well, let's start with going through an example. So let's say I'm an organization, I release 5 foundational models to my business. This is a nice mix of we have some LLM providers, some things from the open source community, a mix of those multimodal and chat completion models, and I provide some choice and agility to my users. Now, some of those users may fine-tune those LLMs, adapt them to their specific domain needs, as we just discussed in the last slide. Maybe as opposed to fine-tuning, some other organizations are customizing their LLMs using retrieval augmented generation capabilities. And so right here, depending on how large your organization is, this could represent your entire organization or maybe even just one business unit. And this shows the need for a mesh-like architecture to scale up or scale down to the models as needed. And while one can debate the uncertainty of the unknown future, one point that I want to drive home is a mesh-like architecture for scalability. The ability to scale up and scale down, whether we're talking about 5 models, 10 models, 1,000 models in the future. Dataiku's LLM mesh is an abstraction layer that sits between your LLM providers and your end user applications. This allows your consumers to develop application using the LLMs that are available today, but still maintain flexibility for the models and what's to come in the future. I want you to think of the LLM mesh as an enabler for your overall LLM Ops strategy. With built-in product capabilities across cost reporting, content moderation, caching, and security permissions, the LLM mesh can act as a backbone to scale your generative AI applications. But this is just one piece of the puzzle. So let's talk further about how we can define a large language model strategy. So large language model operation encompasses the processes, the techniques, and the tools of deploying and monitoring large language models in a production environment. And I like to think of LLM Ops as an evolution of MLOps. There's a lot of things that are similar. We're deploying and we're monitoring models in a production environment. We have to ensure that we have the right security and permission on these models as well. But let's talk today about what's different. And that is, how do I effectively and efficiently manage these non-deterministic machines in a production environment? And this isn't the only thing that's different, but it's where we're going to focus on today, because this is the first hurdle businesses find when they're trying or they're looking for a solution to. And so let's talk about how we can have deterministic strategies for LLM Ops, why this term exists, and we'll uncover why it exists by looking at the differences between AI/ML and LLMs. So, if we think of the model development lifecycle, when we're working with AI and ML, we spend a majority of our time on those first 3 steps. We're ingesting data, we're preparing data, we're doing feature engineering, we're training multiple machine learning models and finding out which one is the best to leverage for our use case. But when we talk about LLMs, we start from a place where the model is already trained. And therefore, we spend our time on things like prompt engineering, adding guardrails, toxicity detection. And we see this shift from time spent on model training to time spent on model inference. And while there's still a manual effort in a way, and it might just have shifted from reviewing or labeling data to now reviewing and changing models, what we see in this shift is we need a new term, this increase in LLM Ops. We need new practices and tools to model or monitor these models in production. And so really what we're going to talk about today is that monitoring and evaluation piece. And why do we need to monitor and evaluate these models? Well, before we go into that, let's focus on the differentiators between AI/ML and LLMs one step deeper. So first, our AI and ML models are data hungry, right? They love data. 80% of our time is spent on model training. But as LLMs, really they need some few or no-shot examples to have a suitable response. That's an interesting differentiator. In terms of computational resources, our AI and ML models require CPUs, while our LLMs require GPUs. Our cost to serve for AI and ML is constrained and expected, but our LLMs have a recurring cost. But as I mentioned before on that differentiator, what's most interesting to me is this model output. Sorry, when I changed to PowerPoint, a lot of my things have changed, it seems like. So let's talk about the output of the model, what makes these non-deterministics, and mechanisms to evaluate them. And why is this so interesting? Well, managing LLMs is like managing 100 interns, right? You give them work and they do it, but you need to monitor and evaluate their output. And monitoring and evaluating that output is difficult because LLMs always provide answers with some level of certainty. In a way, they're almost like the smartest 6-year-old you've ever met. They're 100% confident in every response that they give. And so we need a way to evaluate and to monitor this. And let's boil this down to 3 main problems. The first, these are non-deterministic machines. What does that mean? It means that the output of the model can change every time given the input. The second is this concept of human review. How do we efficiently scale a human-like review without having the time and burden of a human reviewing all of this information? And then the third is this concept of recurring cost, right? We understand that there's that cost to serve, as I mentioned before. How do we effectively monitor that cost? But as my first boss told me, Amanda, never come to me with problems, come to me with solutions. And so in the next 20 minutes or so, I'll be walking you through how we can solve these problems in Dataiku. And the first is implementing this LLM as a judge approach. The second is adding guardrails and automated monitoring to that approach. And then the third is building an LLM cost review dashboard. That way we can look and monitor and understand where all of these costs are coming from to ensure we're actually getting a return on our investment. So I hope you're all paying close attention, and if you are, then you should be a little bit skeptical of this approach. Right? I comment that the biggest problem is reoccurring cost, and then the solution is to use LLMs to evaluate other LLMs. And yes, that approach is a bit meta, but there have been promising reports that this LLM as a judge approach is the most promising way to mimic a human-like review. And we'll talk about more of those stats later, but we'll start by just explaining how we can implement this LLM as a judge approach using our illustrative use case. Great. Let's see it in action. So the use case that we're going to go through today, it is an example that we see often. Dataiku has a lot of documentation online about how our product works. We want to build a chatbot on that documentation. But if you've never heard of Dataiku, I'll explain what that is in a little bit, but we're known for our customer support. It's fast, it's reliable, it's quick, easy to the point, and so we want to make sure if we're using this automated approach, we're going to monitor those outputs effectively to make sure that we hold these responses to the same caliber as our internal support team. And so what we're going to do today is we're going to build out a RAG application in Dataiku. We're going to use components of the LLM mesh that I described, and we're also going to use LLMs hosted by Databricks. Then we're going to implement and explain that LLM as a judge approach, and we're going to use MLflow to also implement custom generative AI metrics. And then we're going to track them over time in something called an evaluation store in Dataiku. We're then going to create metrics on our overall pipeline performance, and we're also going to define this weighted score for model evaluation. And then we're going to alert our users if any of those metrics go outside our defined threshold. And finally, we're going to monitor all of these LLM costs across our projects with the LLM cost review dashboard. That way we can really be sure that we're spending the right time and effort on the right problems. All right, so let's go with step 1, building out a RAG pipeline. And what I'm going to do when I'm showing this as action is I'm going to switch between my slides and showing you what some of this looks like in Dataiku. That way you can kind of get a taste and we're not just going on slides only. So the RAG pipeline, this RAG architecture, retrieval augmented generation, is quickly becoming the industry standard for developing chatbots. And why this is because it gives you the ability to create this vector store or knowledge base on your specific information. And then the LLM can prompt the knowledge base to get that information and respond with the question. So it reduces hallucination, maintains up-to-date information, and gives you that customization without actually having to fine-tune or changing the underlying parameters of the model itself. So let's review quickly how this RAG architecture works. So we start with our documentation. As I mentioned, right now, it's all of the information online about Dataiku. We split that to chunks, and we embed it in our vector store. What this means is we're taking that text, and we're turning it into a vector, which is a numerical representation of the text. Once it's in our vector store, when we have a new user question come in, we retrieve the top most relevant chunks from that vector store. After we have those relevant chunks or context, we append that to the final prompt, and then we take this prompt and we query the LLM and we get our generated answer. And if we remember back to that model development lifecycle slide, this is almost like our steps 1, 2, 3 in LLM world. So we're still ingesting data and we're preparing data, but this is much easier and faster than, let's say, combining 10 tables and doing feature engineering for weeks on end. And it's also super fast in a tool like Dataiku. So let me show you what that looks like now. Okay, so Dataiku, we're a collaborative AI and machine learning platform that covers the full analytics lifecycle. We just won Databricks' Innovation Partner of the Year. Last year, we were Databricks AI Partner of the Year. You can think of Dataiku as the visual interface that sits on top of your Databricks Lakehouse computing infrastructure. So what you see on the screen here, this is a visual representation of how your data is moving and transforming from left to right. This is the entire use case that we're going to be talking about today. In that white box, that's me building out my RAG pipeline that I'll go over. And then the second box, the yellow box, is when we're talking about implementing that LLM as a judge approach. So let's start with building out the RAG pipeline. Awesome. So when building out the RAG pipeline, like I said, we have our documentation. What we did is we scraped the web and got information on Dataiku. These are HTML web pages. Then we use what we call a plugin. A plugin is one of our visual components that we have in Dataiku. In this example, we're doing simple text extraction. So we're taking that unstructured data in the form of HTML, maybe it's PDFs, Word documents, and we're turning it into a structured data source. What's cool is once we do that, our data is directly written to Databricks. So this means as I extract my data, I load it into Databricks, it's directly written to the Lakehouse. That's taking a second. We'll go back to that later. It might have popped up. There we go. Great. Now we'll go and we'll add what we call our LLM recipes. So in Dataiku, you apply recipes to do any type of data transformation. We have these visual recipes, we have the code recipes, which we'll talk about after. And then we have our LLM recipes. In our LLM recipes, we'll add an embed recipe. In the embed recipe, we can select things like what's the knowledge column that we want to turn into vectors. Then down here, which I don't think you could see, here I'll go to edit. You can choose which embedding model you want to leverage for this embedding. So in our case, we're using that model hosted by Databricks. The LLM mesh also allows choice in terms of the vector store that you want to store this information in. Once I create my knowledge base or vector store, that's what you see in pink. Now I have new questions come in about Dataiku. I have questions that maybe users are going to ask, and I have these reference answers. Now I want to create a prompt in our prompt recipe to prompt the LLM to retrieve context from the knowledge bank and answer the question. So again, I can use a prompt recipe in Dataiku. You can see that choice and agility that you get with something like the LLM mesh. So in our cases, I've only loaded models from Databricks, but you can have other LLM providers here as well. But we can see at the bottom, I can leverage that retrieval augmented model. So I select my retrieval augmented model, I create a nice prompt, and then I can go ahead and run this. The output, right, is my generated answers or responses. So I have my question, I have my reference answer, and then I have my LLM output. And as I described before, all of this data is being written directly to the Databricks Lakehouse. All right, let's go over what we just did. So we used that text extraction plugin to move from unstructured data to structured data. We wrote that output directly to the Databricks Lakehouse. Then we leveraged the embed recipe to turn our text into vectors, that numerical representation of the text. We selected that embedding LLM hosted by Databricks. Then we added our prompt recipe. We used another model hosted from Databricks. And now we have our outputted generated response. But this is a talk about LLM Ops. And what I said before is that we hold our support team to a high caliber, and so we need to make sure we add the right monitoring and evaluation mechanisms to this output. And so how we can do that is by implementing an LLM as a judge approach. So before going into discussing what that looks like, let's just talk about why evaluating natural language is hard. Well, we spoke about that's because of the non-determinism of machines, and that's definitely true, but the reason why outputting natural language is hard and evaluating it is because if you give an LLM, if you ask them to summarize 2 news articles, it would do so, but it wouldn't give the same summary, it might not give the same words, and it might give a different word order. And so that's why traditional NLP techniques that you might be familiar with can extend to our LLM ops types of strategies. So let's look at an example. So I have the question, what is Dataiku project library? I have an expected or reference answer, a ground truth, and I get my first RAG-generated answer. So it's a place where users can store objects and functions in order to reuse them within a project. That's true. That is what a code library is. But we can see it's not the same words as our expected answer. And that's okay. We just have to make sure our evaluation metrics are sensitive to this. Let's look at another answer. A Dataiku project library is a collection of books curated by Dataiku's team of librarians. Okay, not far off from an LLM to think, right, that a library has something to do with the collection of books. But we know that this LLM hallucinated the response, right? Dataiku is an AI and ML platform. We're not a public library. And so we need to pinpoint where in our RAG pipeline could our LLM have generated this answer? Does it have to do with the vector store? Did we by accidentally put in some public books in there and that's where it's getting some context? Do we need to refine the prompt? And this is really where an LLM as a judge approach can help you understand and understand where you need to refine that RAG pipeline. Okay, so how does this approach work? So LLM as a judge, the approach uses an LLM as a surrogate for human reviews. And a report released by Databricks shows that this approach is very promising. Over 80% of the time, the grade produced by the LLM was exactly the same as the grade produced by the human reviewer. And over 95% of the time, it was one scale different. And essentially how this works is you provide some metrics, what you want the LLM to judge on. You define that metric. You create a grading system or rubric. In this example, we'll use everything from 1 to 5. And then you provide examples of what a 1 response looks like, 2, 3, 4, and 5. But lucky for us, MLflow has these pre-canned metrics already available for us. So remember, when I'm dealing with the RAG pipeline, I have my question, I have a retrieved context, what I'm getting, I have my generated answer, and I have my reference answer on the bottom. Well, MLflow already has defined specific metrics that makes it helpful to evaluate all of these components. Things like faithfulness. Is the answer grounded in context or facts? Context and answer relevancy. as well as context recall and answer correctness. So how correct is my answer based on the generated ground truth? But what's cool is that in MLflow, besides having these predefined metrics, you can also create your own. And so I'll also show you how we create our own metric, professionalism, that allows us to make sure our responses are not too formal or not too informal. So let's take a look how we can implement this LLM as a judge approach in Dataiku.
All right, so we showed how you can build that RAG pipeline visually.
But what's nice about Dataiku is that you can also implement these code recipes. And implementing code recipes really allows you to extend the product to what the latest and greatest research or open source projects are out there. So this is helpful when working with MLflow. So I'm going to show you this code recipe. I'm not going to go through every single line here, but I just want you to understand at baseline what is happening. So I can do things like select the model that I want to use for an LLM as a judge approach. So in this case, I'm using GPT 3.5, but you can swap this to different models, models hosted by Databricks, etc. I'm also using a LLM that doesn't have a cost as a judge. So an open source model, BERT score, this allows you to score your reference answer with your generated answer. So just another metric that we can include to track over time, because it's important to balance those costs, as I said before. Here is where I define that custom metric for professionalism. So we can see here I'm providing the input, the output, the score, the justification. Those are my examples. I provide two. So I applied an example of what a 2 looks like, and a 3 looks like, a 4 looks like. And then I use the MLflow API to actually make this GenAI metric. I define it. I put in the grading prompt, so that scale of 1 through 5. I put in some examples, and I also put the model that I want to use. And then I can run this all with MLflow, using the MLflow, as you know and love, as different experiments. And the nice part about running this as different experiments is that I could potentially compare different LLMs as judges. So maybe I start with GPT 3.5, switch to GPT 4, Claude, you name it.
So two cool things that you can do in Dataiku. All of these experiments can be tracked through the experiment tracking tab.
So this is a nice visual interface to just show how these metrics are changing with different runs. As I said before, really nice when you're comparing different LLMs or potentially you are adjusting that grading scale.
And then when you find the metric that you want to standardize on,
you can store all of these metrics in an evaluation store in Dataiku. So this is how you track those metrics over time. And what's helpful about tracking the metrics over time is you can see if there's a drift. And so on the screen we see, there's two things that are the glaring spikes. Our relevance is going down. That's showing the relevance of our knowledge base. So maybe it's time to update that, and we'll talk about that in a bit. And then our professionalism is going up. Our LLM is feeling more professional each day. That's good, as long as it just gets too formal, right? We want to maintain this cool vibe of Dataiku. All right. So using that LLM as a judge framework, we just showed how you can do experiment tracking with MLflow and Dataiku, and you can also track metrics over time in evaluation stores. And this is a really good way to set this up. But we can't expect users to log in every single day and watch this line go down and go up or know what to do, right? We want to add some alerting or monitoring to know if one of these metrics is outside a different threshold. Let's tell our developers, let's tell our business users, we need to do something here. But before we get into that, let's talk about some tips and tricks of implementing the LLM as a judge framework. So first, you can implement a weighting system, right? We spoke about 6 metrics that we were tracking, from BERT score to professionalism and things like that. You can create a weighting system to factor to your business needs. And this can also be tuned for each application. So for our example, we value correctness. We want to make sure that they're giving a correct response, but we also want to make sure they're, in that correct response, they're not using slang or doing anything super informal. So I'll show you in a few slides how we implement and create this weighting system. You can also compare LLM as a judges using those experiment tracking. And the report from Databricks also showed that using GPT 3.5 as opposed to GPT 4 drove down the cost by 10x and increased the speed by 3x. So really important to compare different LLMs as judges. And then you can also leverage combined strategies. So lower the temperature on your LLM as a judge. Implement a chain of thought thinking, different prompting to make sure you allow the LLM to reason before it provides a response. All right, let's start alerting. So what I'm going to do is I'm going to set thresholds to track metrics over time within that evaluation store. So this is my evaluation store. What we can do in Dataiku is define metrics and checks.
So I add some status checks.
In this case, I want to make sure that my mean of correctness doesn't go below 3. That's average, right? Don't want definitely anything below average. If it is, if the correctness is really low, let's send a warning.
I also add some additional things on professionalism and faithfulness.
Now I can have these checks running each day to make sure, again, to fail if error or raise a warning. And how this all becomes automated is through what we call Dataiku scenarios. It's almost like our orchestration layer. Here I can do something like create a Slack alert, and I want to verify and run those checks in my evaluation store, and then send a Slack message to my users. Hey, there's something wrong. All right. Now let's talk about the weighting system. So each of these records, after it's going through the LLM as a judge approach, gets a score assigned to it. And like I said, we want to create a weighted average, 60% correctness, 20% faithfulness, 20% professionalism. And so we can implement this weighted average in Dataiku, and then we can add a flag to know what can be passed and just sent right directly to our customer, and what needs to go through a manual review. And so in my 10 examples when I was building out this demo, 80% of them passed. That's a huge time savings, right? Maybe considerations that we can think of offsetting the cost of the LLM that we are using to generate the response and as the judge. So let's see how that looks like in Dataiku.
So our prepare recipe is pretty powerful.
It allows you to do a lot in terms of preparing data. In our example, we create
that weighted score in terms of a formula.
Nice weighted score here.
And then we can do things like add an if-else statement.
To know if that weighted score is greater than 3.5, we pass. If not, we send it to manual review.
The cool thing about this is even though this is a visual recipe,
all of our visual recipes can push down the execution, so all of this is being translated to SQL under the hood and being executed on Databricks.
All right.
So we've shown how we can set up that RAG architecture, we can evaluate and track metrics, we can develop a score to know when to pass. Now, how do we understand how much money we're spending here? And that's really where the LLM cost review dashboard comes into play. So as I mentioned with the LLM mesh, everything you do in Dataiku is audited. This means that all of those actions, all of those API calls are logged, and then the estimated cost is associated with that. And so what becomes really powerful is you're able to build something like this LLM cost review dashboard. Video isn't working. But the LLM cost review dashboards allows you to do things like view the estimated cost, filter on a specific LLM type or project key, and allows you to track your metrics over time or across a specific project. And so why this is helpful is just like anything in AI, your LLM Ops strategy will be iterative. And this way you can look at which projects are spending a lot of money. Am I spending too much money on my LLM as a judge? Should I instead go back and spend or reallocate those funds to fine-tuning? Maybe I don't need as strong of an evaluation strategy. So these insights are very powerful. Great. So to wrap up, what do you want to take away today? Well, the first, that LLM mesh that we discussed earlier, that enables scalability. Enterprise need a mesh type architecture to scale up and scale down. We've learned about the LLM as a judge approach, but not just how to implement it, how to evaluate it, adding the proper guardrails to our LLM system to make sure that we're monitoring and evaluating these in production. And then finally, how we need to monitor and alert on those LLM costs. I want you to make sure you're not just going back and suggesting we query each LLM 3 more times to implement this LLM as a judge approach, but instead make sure you have the right mechanisms in place to track and monitor and gain insights into the ROI. So with this information, I challenge you to develop an LLM Ops strategy. Try implementing that LLM as a judge approach. Come talk to me about this or Dataiku at our booth number 85. But most importantly, you want to implement an LLM Ops strategy or you might become the next viral internet meme. Thank you.